Hello my friends, in this video I want to talk about the introduction and VHDL invariants. I would prefer to use Nexus for implementation part of our work. So in the next slide, the features of this board will be discussed. Nexus 4 board is a complete ready-to-use digital circuit development platform based on the latest RTX7 field programmable gate array with high speed and high capacity, and with external memories, collection of USBs, Ethernet. It has several built-in peripherals, including accelerometer, temperature sensors, MEMS, digital microphone, speaker, amplifier. A lot of device allows the Nexus for to be used for a wide range of design. You can see each related parts of each element in the next slide. The specified of each element in the previous slide is described in this slide. The Nexus 4 power supply can be turned on by SW16. The Nexus 4 can receive power by USB, JTAG, J6 or external power supply. Also, the Nexus 4 contains two external memories. I will present about how to write data in a SDRAM for future projects. Another things, the Nexus 4 board contains two 4-digit common anode 7-segment LED display. VHDL is very high-speed integrated circuit hardware description language. Is a description language used for describe the hardware. VHDL supports these features like design methodologies and their features, sequential and concurrent activities, design exchange and documentation, larger scale design, a wide range of descriptive capability. VHDL is a hardware design language. When you are working with VHDL, you are not programming. Actually, you are designing hardware. It means your VHDL code will be executed at the same time. VHDL is a concurrent language, although you can model the sequential circuit by VHDL. VSL is language used for implementing the hardware, and the FPGA or a field programmable gate array is a device for implementing your VHDL code. There are several features of VHDL you should know before moving forward. I start with VHDL invariants. One of them is case sensitivity. VHDL is not case sensitive. It means both of two statements, as you can see in the figure, have the exact same meaning. Don't worry about the capital or small letter. Second is white space. VHDL is not sensitive with white space or tabs. If you want to write any comments, you can create by two consecutive dashes. VHDL synthesizer ignores anything after two dashes. Every statement in VHDL must be terminated by semicolon. For case loop statement or if loop statement in this session, I just point to the simple format of these statements, and I will discuss about more than in the next sessions. For example, every if statement has a corresponding then component. Each if statement is terminated by and if. If you want to use the else if, you should write else if. Each case statement is terminated by end case. Each loop statement has a corresponding end loop statement. Uh, what is the identifiers? Identifiers include variable names, signal names, and port names. Identifiers should be self-describing. It means the text you want to apply for identifiers should provide information as the use and purpose of the item for identifier represents. Identifiers can be as long as you want. Shorter name make for a better reading code, but longer names present more information. I suggest you choose a short, meaningful name. Identifier can only contain a combination of the letters A to Z and digits 0 to 9 and underscore. Identifier must start with alphabetic character. Identifiers must not end with underscore and must never have two consecutive underscore. In this slide, you can see some valid identifiers and invalid identifiers. For example, data underscore bus is valid because it describes well for the bus of data. But 3bus underscore val not valid because it begins by a number and so on. You can see more example in this table. There is a list of words that have been assigned for a special meaning by VHDL language. These special words usually referred to as reserved words and can't be used for identifiers when writing with VHDL code. You can see some of them in this table and the table on the next slide, like all, in, is, new, loop, of, and so on. This table is a continuation of previous table on the previous slide, and you can see more reserved words of VHDL. Thank you for following my lecture. Please like this video to support and encourage me.